Hi, my name is Akshaj and this is episode number 9 of Python Mastery. Python has three built-in numeric types. Int is for whole numbers, float is for decimals, and complex for numbers with an imaginary component. And we'll cover all three in this video and run the type checks throughout and look at every arithmetic operator Python gives you. And end with one of the most genuinely impressive things Python does that most language does not: unlimited integer size. So we'll start. We are here at the numbers.ipynb file, and what we'll start first is that we'll assign three variables x, y, and z with integer numbers. X will get 10, let's say. Y will say let's get -4, and z is getting 0. And now we'll try to check the type of these. So type of x, similarly type of y, and some type of z, and we'll run this. So what you can see here, that the x is getting a type integer, as you can see here, y is getting an integer, and z is also getting an integer because these all are whole numbers. Whole number in Python basically is positive, negative, or 0, no decimal point or any fraction numbers. You can also write large integers which underscores as visual separators. For example, I have a population variable where I want to use say this much, say 400 yes. And if I want to print population, and then I want to see the type of population, and you can see it is a big number. It is like this much, and it has we have printed it, and here I can see the type. It is an integer. So large integers can be used used as underscores with visuals as separators, and Python ignores them completely, and they are just for readability of ours. So now we'll talk about floats. Floats, while the integers talked about whole numbers, floats on the other hand will talk about decimal values. For example, pi value is 3.14, and we have if you want to see the print of pi, the type of pi, you can use a type function, and as you see, it is a float. A float is any number with a decimal point, as we talked before. The moment the dot appears, Python reads that a float no matter what, not an integer. That's a distinction that matters. And Python gives us 7 arithmetic operators, and we'll check all of them one by one. So we'll have two values with variables a and b. For example, a is 15 and b is 4. Now we'll start with we'll start with addition. So print a plus b, that is addition. Now we'll do print a minus b, that is subtraction. Now we also can do multiplication by using the star option, and we use a into b, and we can also use division, as you can see here, a divided by b. You can also use floor division. And if you may ask what is the difference between division and floor division, basically, as you see here, division gives us a float value, and floor division gives us an integer value. And you can also use the modulus function using the percentage symbol, as you see here. And you can also use exponents by double stars. For example, print a b. And here you can see we have performed 7 arithmetic operations that Python allows us. Most of these are familiar, and some new, like floor division, modulo, and exponents, are shown here. But now we have to remember one small thing about floats you need to see. For example, if I want to print 0.1 plus 0.2, it gives us a big decimal value. This is not a Python function or Python bug. It's a hardware limitation because floats are stored in binary, and 0.1 has no exact binary representation, same as 1 by 3 has no exact decimal representation. The tiny error compounds into a big number, as you see here. So for most programs this does not matter, but for anything that involves money or precision, use the decimal module as we show as above, and we'll cover it later. So for now, you have to know that floats are approximate, integers are exact. So now we'll talk about large integers. So back to what we opened with. Most languages store integers in a fixed amount of memory, 32 or 64 bits. That means there's a maximum value they can hold, and if you go over it, the number wraps around it or overflows. So but Python does not do that. Python integers are very precise. They grow as large as your RAM allows, no ceiling. For example, if I want to use exponents, so what I'll do, I'll write a print function int, and I want to use 2 to the power of say 100, and I'll write another one, print 2 to the power of, let's say, 1000, and then I'll assign a variable called factorial and use 1, and I'll add a small for loop where I say for I in range say 1 to 101, the factorial should compound as with I, and then at last we'll print factorial, and we'll run it as in the range sorry, range, spelling mistake, range. The last one is 100 factorial, which is 158 digit long because I've memorized it. Python handles it without breaking. This matters in cryptography, scientific computing, or competitive programming, anywhere where numbers get unusually large. In most day-to-day code, you'll never hit the limit, but in specific cases, as we talked before, you may need it. So that's very important to keep in mind. And last, we'll talk about complex. If you have done engineering maths or signal processing, you have met those. Complex has a real part and an imaginary part, written as a plus ib, like this, a plus ib. This is how you write a complex number. So where I is the imaginary unit. So if I'll write a small variable where I'll use complex of say 2 comma 3 parenthesis 2 comma 3, and now I'll try to print the C, and we'll also check the type of C. As you can see here, we have 2 plus 3j, which is where 2 is the real number and 3 is the imaginary number. Now if I want to see what the real number is of the complex, I can use a c dot real function, and if I want to see the imaginary, I can use this. And as you can see, we can write complex numbers literally in Python. Arithmetic works exactly as you'd expect from maths. Python handles imaginary units correctly. So for example, I have two complex numbers, says 2 plus 3j, and let's say 1 minus 1j. And now I want to perform arithmetic operations. So I'll do c1 plus c2, and I'll also do subtraction, c1 minus c. Let's not do subtraction, let's do something different, let's do multiplication. So now I'll run this. So most beginner things don't touch complex numbers, but if you go into electrical engineering, signal processing, or say scientific computing, it's already built in, so no library is needed. And now, one habit that's worth building from this video is when something isn't behaving as expected, check the type before anything else. So for example, I am writing an input function where I'm writing a message, say enter a number, and now I'll try to print the type of the number we want to input, and then we'll write another variable called y, and we'll write the integer of x, and then we'll try to see the type of y, and then we'll write a float of x, and we'll see the type of z. So first, as we talked in previous videos in this previous episodes, a string input will take the default value as a string. So when I enter a number called say 20, and when I try to print it, it gives me a string, because we know because input takes a default as string. And now what I got, I stored the value, say 20, in x. Now next thing what I'm doing is I'll take the x, which is 20, and I'll convert a string to an integer and store it in y. Then when I print the type of y, it gives me an integer. That now if I want float, I can use type conversion and use the float operation. And when I see the string of 20 into a float, it converts and store in z, it gives me a float as you see here. So type is your first debugging tool. Before you check your logic, check what you are actually working with. A wrong type explains more than bugs than wrong arithmetic ever does. So let's do a small recap of what we have learned till now. Int type function is basically whole numbers, exact, unlimited size in Python. Float are decimal with approximate due to binary storage, and complex are real and imaginary parts, and written as a plus ib or a plus bj, whatever you like, and it's useful in engineering and science. And we have 7 operators like plus, minus, multiplication, division, etc, etc, which you have to learn. And then we talked about the type function, which is our first debugging instinct, which we use early on and often. So that was the video, and if you liked it, please like and subscribe and share this video. Thank you for watching.